Okay, I'm back. So, we left off here. X plus 1, x2 minus 3, x squared minus 4x plus 12. Our new polynomial, let's try. We tried 1 doesn't make sense because it wasn't initially a factor. Negative 1 we've tried again. Let's try 2. So 2 cubed is 8. So f of 2 is equal to 8 minus, what's 2 times 2? 4. 4 times 3 is negative 12. Negative 8 plus 12. And hopefully you can see that the negative values are negative 20 and the positive values are 20. That's equal to 0. So that means 2 is a factor. So our binomial is x minus 2. So we're going to do long division again. And you can use different techniques to factor a degree 3 polynomial. You could use factor by grouping as well, actually, because there's 4 terms, right? But that's fine. I'm just going to do it this way. So x squared, x cubed minus 2x squared. There's another sign there, so cancels. Minus 3 plus 2, that's going to be negative x squared. Minus 4x, that's going to be minus x. Minus x squared minus 2x. Negative sign there, positives. Negative 4 plus 2, that's negative 2x plus 12. That's going to be negative. No. Nope. Why did I make a mistake? Hold on. Okay. I found out where I made a mistake. See, this is what happens when you go too fast. And showing my work. I actually do better when I don't show my work. So here in this step here, I multiply by x squared. X squared times x is x cubed. X squared times minus 2 is minus 2x squared. Subtract the two values. This cancels. Minus 3 plus 2 gives me negative 1. Now I multiply by negative 1. So negative 1 times x is negative x squared. Negative 1 times negative 2 is positive 2. And see, remember, if you're not getting a remainder of 0, you know you made a mistake. So this becomes negative 4 minus 2, so that's negative 6x plus 12. And then we multiply by negative 6. Negative 6x plus 12, remainder of 0. So we know that x minus 2 is a factor. So now we've reduced down to a quadratic. The initial factor was x plus 1. Now we have x minus 2. And we have x squared minus x minus 6. This is pretty straightforward. It's a quadratic. I'm sure you can find two numbers that add up to, let's see, m plus n, the middle term, which is negative 1, and m times n, which is negative 6. Looks like a 2, 3 to me. 2, negative 3, and 2, negative 3. Yeah, that works. So this is going to be x plus 2, x minus 3, x minus 2, and x plus 1. And that is how we factor our polynomial. And since they make it equal to 0, I'm sure they did in the initial question. Oh no, they're asking to find the zeros. Okay, so we got to make it equal to 0 and solve. So x is equal to negative 1, positive 2, negative 2, and positive 3. There we have it. That's the answer. And negative 1, 3, negative 2, and negative 2, and solutions. Okay, I think we're just going to do more examples. Yeah, let's do... Okay, fine. Let's do this. So yeah, same, find all real solutions for each polynomial equation. So this is degree 3. We have an a value of 2 and a b value of also 2. So let's write all the factors. It's just going to be plus or minus 1 and plus or minus 2. Same for this, so I'm not going to write it. And I guess maybe I should write it. And b over a is what we check. And b over a can be, since you always divide by 1, 1 is always a factor, so you always just write all the factors of b, which is 1 and 2. And then the other value you're dividing by is 2, so we have half, and 2 divided by 2 is 1, which we already have here. So we have 1, 2, 3, 6 values to check. So let's check all 6. 1, once again, easiest one to check. 2 minus 3 minus, might be easier to put that 1 there, minus 1 minus 2 when you're doing this. That's clearly more negative than it is positive, so 1 doesn't work. Let's try negative 1. So negative 2, negative 3, positive 1, minus 2. So I switched the signs for the odd exponents, so 2 became negative 2, and negative 1 became positive 1. Let's add them together. Once again, this does not equal 0, clearly. All right, so we tried 1 and negative 1. Let's try 2 and negative 2. So positive 2 is usually easier, so let's do that. That's going to be 2 times 8, minus 3 times 4, minus 2, and that's 16, that's 12, that's 4. When you add them together, that's, wait, what? Does this work? Wait, hold on. 2 times 2 times 2, 8. Yeah, 8 times 2, 16, yeah, okay. 2 times 2 is 4, yeah, negative 12, negative 2, negative 2. So, I think, yeah, this is 16 minus 16 is equal to 0. Okay, so, all right. I thought there was a trick to this question. No, it doesn't look like it. I think that's it. So f of, what did we substitute? 2 gives us a value of 0. So a factor theorem means that x minus 2 is a factor of this equation here. Let's see. So this becomes 2x squared, 2x cubed minus 4x squared, x squared positive minus x plus x, x squared minus 2x. It's going to be x minus 2 plus 1, and then x minus 2, and yes, we have a remainder of 0. Okay, so 2x squared plus x plus 1, and x minus 2. So let's factor 2x squared plus x plus 1. So two numbers that add up to the middle term, which is 1, and two numbers that are a product of a and c, so 2. And here we have 2 and 1 are the only possibilities. So 2 and 1. So it could be positive 2 and positive 1. That's going to give me 2. But if I add them, that gives me 3. Or a negative 2 and negative 1. And if I add them, that gives me 3. So that means this is not factorable. This quadratic is not factorable. So our final answer is just x minus 2 bracket 2x squared plus x plus 1. And the only real solution is x equals 2. Okay, that was it. That was, yeah, that's what they got. Oh, let's do difference of cubes. Perfect. Yes, let's do, this is finally something a little bit more different. So by the end of grade 12, you definitely should have this memorized, or by the end of this unit even. Difference of cubes is expected. You definitely should know this going to calculus. So by the end of this course for sure. So what is difference of cubes? The same thing like difference of squares. A squared minus b squared is equal to a plus b, a minus b. In that we're just figuring out what a and b are, and then just substituting it into this format. So So in this case, what is my a value? Is it just x? No, because if it was x cubed, that's just x cubed, and this is 8x cubed. So my a value cannot just be x. My a value has to incorporate the coefficient there, which is an 8. So what you need to do is you need to rewrite this as follows. A singular term that's being cubed, and 2x being cubed gives me 8x cubed. So that's how I can write that. And this is pretty straightforward. What's cube root of 125? It's just 5. 5 cubed. 5 times 5 is 25 times 5, 125. All right, so here we have our a values and our b values. So this is a and this is b. And there's a plus sign here. So a cubed plus b cubed is equal to a plus b, which is 2x. That's my a. And my b value is 5. So 2x plus 5. My a value is 2x. So this is going to be 2x squared like that. And we'll simplify in a moment. And my a value once again is 2x. And my b value is 5. And then we have 5 squared there. And simplified, that is 2x plus 5. 2x squared is 4x squared. Don't forget to square the 2. And this becomes minus 10x, because 5 times 2. And 25. And there we have it. That is how you can use difference of squares to help you factor, or, sorry, difference of cubes, I apologize. Or sum of cubes, I guess, technically. And now we can factor our quadratic. Look for two numbers that add up to negative 10. And the product of those same two numbers will give you a product of 100. Okay, so we have to write the factors of 100. So 1 and 100. If you're not sure, you can just do on your calculator, do 100 divided by 1, and then 100 divided by 2, and 3, and so on. And then the answer that you get are the factors. So like, for example, 100 divided by 2, the answer is 50. So 50 and 2 are factors. 100 divided by 3 doesn't work. That's not an even number. But divided by 4 does work. And that gives me 25. So 25 and 4 are factors. 5 works. That's just 20. 6 does not work. 7 does not work. 8. Does 8 work actually? It's 0.5. So no, it's not a whole number. So 9 doesn't work. 10 works. So 10 and 10. And once you're repeating, 10 and 10 are repeating, that's it. These are all the factors of 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or technically 9. So 10 is repeating. Let's check now. Would any of these give you a value of negative 10 when added together? So, or subtracted. And I don't see any of them working out. So I'm going to say that this quadratic is unfactorable, and this is the final answer. So the only solution is 2x plus 5 is equal to 0, and x, bring the 5 over, negative 5 over 2. There you go. And yeah, see, that's exactly what they got. No real roots. Oh, they can just do a check, actually. Just do the discriminant check. You can use a, yeah, I was going to say you can use the quadratic formula. But yeah, okay. I think that is it for lesson 4. Let me see, what's this? Families. I don't think we're going to go into that today. I think I completed all of this. Yeah, this is all the same stuff. All right, hope you had fun, and see you next time.